Under the guidance of Dr. Saurav Mehta, we are going to do this session. Our group members are Prashant Bhange, Aniket Bhonde, Mayuri Dekate and Dhanashri Dhabde. Now we'll see about the GSM overview. GSM was originally known as Group Special Mobile. Now it is known as Global System for Mobile Communication. It is based on TDMA or FDMA technology. It was started in Europe since 1982. We'll be seeing about the features of GSM. Use of SIM cards. SIM is a memory device that stores information such as the member's identification number, the network and country where the subscriber is entitled to service, privacy key and other user specific information. Second feature is on-the-air privacy. Unauthorized interception of GSM transmission are virtually impossible. The privacy is made possible by encrypting the digital bit stream sent by GSM transmitter according to the specific cryptography key that is known only to the cellular carriers. The key changes with the time for each user. Another features are roaming in European countries and full international roaming capability, control of transmission power and frequency hopping. Now we'll be seeing about the basic services provided by GSM. The telephony is the basic teleservice. Telephony analog speech signal are digitally encoded and then transmitted through the network as a digital data stream. Other services are emergency calling and voice messaging. Emergency calling, where the closest emergency service provider is notified by dialing 3 digits. Other service provided are bearer service, that is low speed data transfer, and group 3 flag service and SMS. SMS is a bidirectional service for sending alphanumeric message of limited length while simultaneously carrying voice traffic. Another supplementary service are call bearing, call waiting, closed user group and caller identification. Now we'll be discussing about the architecture of GSM.
The GSM system architecture consists of 4 major interconnected subsystems, namely mobile station, base station subsystem, network and switching subsystem, and the operation support subsystem. First, mobile station MS. The MS includes mobile equipment, subscriber identity module SIM. At the time of manufacture, an international mobile equipment identity IMEI, which is not easily alterable or removable, is programmed into the NE. The International Mobile Subscriber Identity IMSI is programmed into the SIM at the time of service provision along with the appropriate security parameters and algorithms. Second, base station subsystem or the radio subsystem. A BSS consists of base station controller and base transceiver stations. Each base receiver station defines a single cell. It includes a radio antenna, radio transceiver and the link to base station controller. Functions. A BSS is responsible for all functions related to radio resources management and the signal processing. Some of the functions are radio resource control, handoff management, frequency hopping and power control, digital signal processing such as channel encoding and decoding. Third one is network and switching subsystem. NSS includes MSC as a central unit, 3 different databases called as home location register, visitor location register and authentication center. It handles a switching of GSM calls between the external networks such as PSTN, ISDN and the BSS in the radio subsystem. It is also responsible for managing and providing external access to several customer databases. MSC. The MSC performs the following major functions: call setup, supervising and release, digit collection and translation, call routing, billing information collection, mobility management, paging and alerting, management of radio resources during a call, echo cancellation. First database, home location register, HLR. It represents a centralized database that has permanent data field about the mobile subscribers in a large area service, generally one per GSM network operator. Second is visitor location register. VLR is a database which temporarily stores IMSI and the customer information for each roaming subscriber who is visiting the coverage area of the particular MSC. The temporary subscriber information which receives the VLR includes feature currently activated temporary mobile station identity TMSI, current location information about the MS. Third, authentication center. As the radio interface and the mobile station are very vulnerable to malicious misuse, a separate authentication center has been defined to protect user identity and the data transmission. Equipment identity register. Authentication center contains a register called Equipment Identity Register. The EIR maintains information to authenticate terminal equipment so that fraudulent, stolen or non-type approved terminals can be identified and deny services.
CDMA is Code Division Multiple Access. It is based on spread spectrum technology, which was invented in Northern America in 1996. CDMA is divided into two parts, CDMA 1 and CDMA 2000. CDMA 1 is further divided in IS-95, IS-95B and JSTD.08. The most widely used standard for CDMA systems is IS-95. In CDMA, each user is assigned a unique code. This unique code is referred as pseudo-noise code, which is very large in bandwidth. That's why it is called as spreading the signal. It distinguishes between different users in radio environment. In fact, the code in CDMA is similar to the frequency slot in FDMA and time slot in TDMA. Each user is transmitting by spreading his narrow band information with his unique code using a simple multiplication process. Hence, all users are now transmitting asynchronously in same bandwidth, thus achieving simultaneous access to a shared communication channel. Mixing of channels from different users will not take place because of their individual exclusive coded format. The code assigned to each user is specially designed to be orthogonal to all other codes. This enables the receiver to easily detect the message signal from particular user by simply knowing the code word used by that user and multiplying it with the received coded signal. This is the diagram of frequency spectrum diagram of the CDMA signal. As we can see, all the users are using the same frequency, but they are assigned different code word. This code word is specifically used for privacy purposes and which does not allow unauthorized access to the other users.
Advantages of CDMA system: multipath rejection, immunity to interference and jamming, multiple access. Features of CDMA system: frequency usage. Many users or a CDMA system share the same frequency. Either TDD or FDD may be used. Soft capacity limit. Unlike TDMA or FDMA, CDMA has a soft capacity limit. Increasing the number of users in a CDMA system raises the noise level in a linear manner. Thus, there is no absolute limit on the number of users in CDMA. Rather, the system performance gradually degrades for all the users as the number of users is increased and improves as the number of users is decreased. Multipath resistance. Channel data rates are very high in CDMA systems. Hence, the symbol duration is very short and usually much less than the channel delay spread. Since the pseudo noise sequences have low autocorrelation, multipath, which is delayed by more than a chip, will appear as noise. A rake receiver can be used to improve reception by collecting time delayed versions of the required signal. Soft handoff. Since CDMA uses co-channel cells, it can use macroscopic spatial diversity to provide soft handoff. Soft handoff is performed by the MSC, which can simultaneously monitor a particular user from 2 or more base stations. The MSC may choose the best version of signal at any time without switching frequencies. Self-jamming. Self-jamming is a problem in CDMA system. Self-jamming arises from the fact that the spreading sequences of different users are not exactly orthogonal. Hence, in the despreading of a particular pseudo-noise code, there is some level of cross-correlation. There will be non-zero contributions at the receiver from the transmissions of other users in the system. Near-far effect. The near-far problem occurs at a CDMA receiver if an undesired user has a high detected power as compared to the desired user. Signals close to the users are received with less attenuation than signals farther away. Given the lack of complete orthogonality, the transmissions from the remote mobile units may be more difficult to recover. The less fading effects. Multiple fading may be substantially reduced because signal is spread over a large spectrum. Now here shall we see the differentiation between the two technologies GSM and CDMA in a tabular form. As you can see, GSM uses SIM cards and CDMA does not are not card enabled. GSM offers international roaming facility whereas CDMA does not. And the further uplink and downlink frequencies can be observed. Also, it should be noted that GSM technique is based on Gaussian minimum scale shift keying method, whereas CDMA is based on quadrature phase shift keying method. Here are the following advantages of CDMA over GSM. CDMA provides increased security over the air interface. The subscriber capacity is 4-6 times the GSM capacity for the same frequency spectrum. The following are the disadvantages of CDMA compared to GSM. Conclusion. From the previous slides, we observed that GSM and CDMA are both frontier technologies having some advantages and disadvantages, but it is upon the user to decide which technology is best suited for him. These are the following references from which we collected the data. Thank you.